All right, hopefully you're still following along here. We have this next part to share with you. Kind of more stuff on powers, hit, and false alarm. Pretty theoretical stuff. Hopefully you're understanding some of the main points here. But let me continue on. There are two other solutions to this situation of making these binary decisions, right? You're saying something's significant, but it might not be. So you're kind of making yes-no decisions with this line in the sand. There are two other approaches that statisticians use to try to deal with this problem. A lot of statisticians really don't like this idea of yes or no, that it's binary, and so there are two other solutions to this. One, and I'm going to refer back to this example of the asthma study. If you remember, we had 3 people in it. We said it has a low amount of power here, but 1, 4, and 7, 2, 6, and 10. And so remember, we got a t-score of 3.46. You remember that the probability was 0.074, so you can get a t-score of 3.46 7.5% of the time out of 100. This is statistically non-significant. Well, another way of dealing with this issue that I would actually use to write this up is a term called marginal significance. Marginal significance. Marginal significance is kind of a definite maybe, if you will. Marginal significance is defined as any result that occurs between 5% of the time and 10% of the time due to chance. In this case, 7.5% of the time is in between that. What a statistician could say about this result is they don't want to say this is non-significant, because then they might have a type 2 error, but they could use the word marginally significant, which would basically say this result is close to being significant but not quite there yet. Marginal significance is where you give some sort of indication that your result is almost significant but not quite. So it's kind of giving a range of uncertainty here, if you will. And if you got this result once again, it said 0.074, a statistician would come back and say, well, how many people in your sample? You'd say, well, only 3. Well, you'd say, oh, you don't have enough power for that situation. So 0.074 would be considered marginal significance. And that's one way a statistician could write this result. The way you would do it is you'd write T parentheses 2 equals 3.46 comma P equals 0.074. You'd say marginal significance. It looks like the program works, but not enough power here. Thanks.